Hello friends, let us now discuss effort of a governor. So what is the effort of governor? It is a mean force acting on a sleeve to raise or lower it for the given change in speed is called the effort of governor. What happens is, if this is your sleeve and when the speed changes, suppose it increases, then some force will act in order to raise it. When the governor is in equilibrium, that is, it is rotating at the constant speed, there is no force acting on the sleeve since it is in the stable condition. So it will be zero. But when the speed is increased, the effort E will be applied in order to move the sleeve. So it will be gradually applied to the value of E. So it will be 0 to E and again it will diminish to the 0 as the governor will apply again the equilibrium condition. So the mean force, total mean force acting will be E by 2 and that is called as the effort. So this is the effort of governor. Let us apply this concept to the Porter and Hartnell governor we saw. Let us now see that effort for Porter governor. We know from the force analysis of Porter governor that height h of the governor can be given by the equation 2mg plus capital Mg into 1 plus k divided by 2m omega square. So we have neglected the friction over here, so small f won't appear. We now consider that our speed has increased by the amount c times omega. So that will change our speed from omega to 1 plus c omega. So our speed is now 1 plus c omega. And obviously if this is an increase, then the effort E or the force E will be applied on the sleeve in order to move it upwards. What we assume it that the same force is required to hold the sleeve at the same height h. We don't allow the sleeve to move. It will remain at the same height h. But in order to hold it at the same height, we will need to apply some additional force and that will be equal to effort. So effort E. So our height now will be given by the equation 2mg plus E, that is additional force applied into bracket 1 plus k divided by 2m. Now the speed has changed. So it will give us 1 plus c bracket square into omega square. Now both these heights are equal. So we can equate these two equations. So we will try to equate them. By equating, we will get the equation 2mg plus E into 1 plus k divided by 2mg plus mg into 1 plus k is equal to 1 plus c bracket square divided by 1. So now we will apply the dividend rule here and we will get the equation by expanding this bracket 1 plus c bracket square. We will get this equation. So this is that equation continued from the previous slide. So here 1 can get cancelled. And next thing we will do is, since the increase in speed considered was a small change, so c was a small factor, so c square will be even further small, so we can neglect it. We will consider it 0. So we will say neglecting c square, the equation will get modified to E into 1 plus k divided by 2mg plus capital Mg into 1 plus k equals to 2c. Rearranging the terms, I can write down E is equal to 2c upon 1 plus k into 2mg plus capital Mg into bracket 1 plus k. Therefore, I can say that E by 2, that is my effort. So this is effort is equal to Cg upon 1 plus k into bracket 2m plus capital M into bracket 1 plus k. So this is the equation for effort of Porter governor. Now if I put the value of k is equal to 1, that is I assume that all the arms of my governor are of equal length, then my equation for the effort will get modified to simply m plus capital M into Cg. If I want to consider the friction, then the equation get modified to E by 2 mg plus F into C. So this is the case considering the friction, but also assuming that arms are of equal length. Now let's see the effort of the Watt governor. So we already know that effort of the Porter governor from our last derivation. So this is the equation. We'll just modify it so that we can calculate the effort of Watt governor. So in case of Watt governor, the arms will be of equal length and the capital M will be 0 since there is no mass placed on the sleeve. So it will give me the equation for the effort of Watt governor. It is simply effort is equal to C into mg. Sometimes the effort is also defined in case of Porter governor as a 1% change of speed. So if I consider that my value of C will be 0.01, and in case of equal lengths of arm, the equation will be E is equal to simply 0.01 into M plus capital M into G. Now let's see the effort for Hartnell governor. Neglecting the friction, we know that mr omega square A is equal to 1 by 2 into bracket capital Mg plus spring force Fs into B. This was the equation we derived from the force analysis of Hartnell governor. Again we apply the same condition, that is our speed is increased by the factor C. So omega changes to 1 plus C into omega and effort is applied to hold the sleeve at same height. So this equation will get modified to mr into bracket 1 plus C square omega square A is equal to 1 by 2 mg plus additional factor E, force E will be added here, plus spring force into B. Now what I have done is I have expanded this and mr omega square A considered together, I know its value is equal to 1 by 2 mg plus fs into B. So I substituted that. Then I have multiplied by B inside the bracket. Then I took these first two terms together and kept E by 2 B separate. Subtract this term from both the sides. So this term will vanish from this side, and on the left hand side I will get, neglecting the C square as it is small, 1 plus 2C into bracket 1 by 2 mg plus fs B minus 1 by 2 mg plus fs into B is equal to E by 2 into B. So if I take this whole bracket common, I will get 1 plus 2C minus 1, that is equal to simply 2C, and 2 will get cancelled. I will get C into mg plus fs into B is equal to E by 2 into B. Next I can cancel this BB from both the sides and I can get the equation for the effort as E by 2 is equal to C into mg plus fs. So this is the equation for effort of Hartnell governor.